We can do it without microphones.
Yeah, and without slides, apparently.
Slides? Oh,
Will we have slides? Oh, okay. Here we have Greece, which is nice.
But it's not our slide.
Yeah, it's close enough, though.
All right.
Do you have a lot of those? We can speak instead of our slides?
We could use other people's slides easily. Slides. Okay, let's start introducing.
I think it's a theme. We should start without the slides.
Yeah,
it's like every talk I deliver today starts without slides. So guys, anytime when you want slides,
in the meantime, we'll talk about the talk. We wanted to talk a bit about how DevOps and the processes around actual building the software happens at the company as it grows from very few people to a lot of people.
What it has to do with Java Conference?
Well, apparently we don't build software in a vacuum. It has to do something or power something or be used by somebody.
Okay, fair enough.
Now, what better way to tell that story if not in the form of a Greek tragedy?
Yep.
Do you know why?
Why? Oh, okay. That's a question not for me. That's
well,
a question for
if you don't know why, let's ask the audience.
Let's ask the audience.
Does anybody know what is a key element of a good Greek tragedy?
What distinguishes Greek tragedy?
Oh, come on. Yes? Someone dies. No,
that's
close enough, good enough.
Well, no, not so much.
The real Greek tragedy, everybody dies.
Everybody dies. So that's a very natural theme for talking about DevOps at scale, right? There cannot be any other way. Guys, any progress on the slides?
Well, in the meantime, why don't we introduce ourselves?
Yeah,
this is Baruch, Baruch Sadogursky,
I'm developer advocate with JFrog. And in this setup, I will represent a software vendor that produces some of the tools that are used in a variety of sizes of companies, all through the scale, from startups all the way to big enterprises. And this is Leonid Igolnik.
I'm a software engineer with 20 years of experience, software manager, been an executive with several of the largest software companies in the world, and we're going to talk about the executive side or the management side or the process side.
The good news about it, we have slides.
Yeah, let's go.
So, yeah, what we are doing is actually a prologue to our Greek tragedy, and we started with represent each other's. Those slides are very handy because they have our Twitter handles here, and since we are extremely interesting guys, you should follow us on Twitter right now.
At JBaruch.
At Igolnik.
Okay, so let's figure out first things first. What the hell is DevOps?
Well, DevOps has been around for a number of years, and still there are very interesting debates on what it is.
I think we shouldn't explain it in the way Greeks used to do it, because I know they loved Venn diagrams.
So we will do Venn diagrams as Greeks love. And I would say the canonical way to explain DevOps is this Venn diagram. We take dev, we take ops, and we create DevOps.
Well, they must have left out Q8 of that meeting.
Yeah, they kind of added it later on.
But the name didn't work, like DevQOps, QDevOps. Yeah.
So they kept the name DevOps. Q apparently it's a big part of it, right?
All right. But there's another way to look at process and evolution of DevOps at any company, which is an intersection of technology, people, and process. And that's the lens we're going to take today. Or alternatively, there is another way to look at this.
No, we don't need any music, especially not now. We're good, thank you.
It's like the Oscars, they're playing us off stage.
I appreciate the effort, we're good.
All right.
Yeah. No, so today we're going to tell a story about a fictional startup company that grows in scale from 3 developers to 100 developers in one development team.
They're called Pentagon, and there happens to be a competitor with a different shape in their name.
So they do mobile payment processes, like some of the exhibitors here and other companies. There is this company called Square, very popular in the United States, and I guess Pentagon want to be similar but different in this regard.
Same but different as the same. Thailand. Let's see what happens. Act 1, we call it the Fire Brigade. Or reactive operations.
Right. So we are going to talk about what's Fire Brigade and why they keep fighting fires.
I think first we need to tell our audience what does the company look like, so let's set the stage.
Yeah, and look at that. Now this looks beautiful. Look behind you. Huh?
That's perfect.
That's perfect, right. Okay, so as we mentioned, we start with a very, very small team of 3 developers. All 3 of them are founders of the company. Yep. They write their product, they write their code.
They came out of defense technology, so on-prem software.
They never did cloud, and this is the first time they actually do something in the cloud, and this payment process is a cloud process, yep. Actually.
Now, they're smart guys, so they know some of the good processes, they know how to write good software.
They are a little bit on a hipsterish side, so they use all the hipsterish technologies.
They were a bit constrained in their old defense jobs.
They're all Java back there, and now they can do
EGBs.
And now they can do whatever they like. So they do JavaScript, they do Node.js, they do reactive microservices, all the cool
stuff you see at the conferences. Absolutely. They couldn't use before.
So this is people, and now let's talk about process.
Well, what kind of process do you have at the company with 3 people?
The process I like, almost no process.
Stickies. Kanban, right? Trello, Stickies, maybe Jira, but most likely it's a whiteboard. They're all in the same room. Don't need a lot of process. Now, the smart guys, even though there is no QA in the name of DevOps, they realized that if you write tests early on, they're cheaper later on. So they started with TDD. They have unit and integration testing. They have CI.
So valid stack. Ops, well.
What ops? They come from the defense on-prem background. Plus, they go to conferences and they hear this buzzword called serverless.
Well, serverless means there are no servers. It means they don't need any ops. They can do without it.
And then they go to other conferences and they hear Netflix that says everybody has root in production. So they said, we'll do like Netflix.
Well, there is another wonderful term from conferences. It's called no ops. Now, no ops sound perfect for guys who doesn't want to do
or don't know what ops does.
So no ops and serverless is the way to go, and those trends are transferred, of course, to the tools that they choose. So they have a very, very limited stack that goes something for managing requirements.
And bugs.
It can be Jira, it can be issues on GitHub, it can be anything you like.
GitHub,
GitLab,
whatever.
Bitbucket or whatever. Travis CI, who knows what Travis CI is? Yeah, a lot of people
don't need to explain it. See, Jenkins in the cloud.
Right, so CI server in the cloud as a service.
And since there is no ops, they choose platform as a service. AWS seems to be popular, so they use AWS Beanstalk. You know, you give it a thing, magic happens, everything runs, and you're good.
Other options might be Google Cloud Platform with their functions. It can be Microsoft Azure, or
plenty of choices
or whatever. Plenty of choices.
Let's see what happens.
Right, so let's go to action.
Well, as a good startup, when you start, what do you do for a while after you started the company? First, you spend a lot of time writing your first version of the product and waiting for the first customer.
So they wait for their first customer.
They have happened to found a conference that sells a lot of tickets that needed their services.
Oh, right.
JavaDay, Kyiv.
Yes, JavaDay Ukraine is their first customer, and they sell tickets, they manage all the payments through it, and it works wonderfully.
So, what do you do as a startup when you find a customer like that? Come on, you guys should know.
And I expect a very definite answer from Victor, namely.
You celebrate, and we will as well.
It's kind of yeah. So they drink. It's the first customer for their startup. It's a very big deal.
Cheers. The party naturally happens like any other parties on Friday, and then we meet our first hero.
Говорят, градус нельзя понижать, but I have no choice.
You have no choice. And that's where we meet one of the founders, our hero, Mykola.
Yeah, Mykola.
He goes home and he has this brilliant idea after partying the whole night.
Yeah, so imagine Friday night, 3 a.m., everybody drunk, and Mykola is the drunkest of them all, and he has the brightest idea of how to improve their code.
So he does.
Yeah, so he codes it.
But they have testing. Everything passes CI, goes to production, everybody goes to sleep.
Right.
And then
Andrei calls. He's very angry.
Do you know that we have a big promotion going on and nothing works?
Nothing works.
Nothing works.
Oh my God.
As a startup, what do you do when you get a call like that from your first key customer? You naturally panic.
Right.
After you panic and relax for a bit, you charge.
Right, and this is very easy for those 3 guys because they are the founders. They own 100% of the code. They wrote them themselves.
We have root.
Absolutely.
So let's go see them in production.
What do you first thing you look for when you have a bug in production? What do you start with?
Logs.
Logs, of course.
Where are the logs?
But we use serverless. There are no servers, so probably there are no logs.
No. I know where they are. We use servers. They're in the cloud.
Oh, let's go to the cloud.
So after a bunch of clicking, if anybody ever used Amazon AWS console, they found CloudWatch.
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 So yes, in
Wait,
the cloud.
I have 20 different things here.
Oh, that makes sense. We have microservices, so we have 20 different services, and we have 20 different logs.
Wait, in my log, in this one, I found one. There's an error, but it's at 4 a.m.
Oh, yeah, I see an error in 2 a.m., and it looks like it's the same error.
How could that be?
How can it be?
Maybe the time zones are different?
Yeah.
Anybody ever had to do time zone acrobatics on the logs? Raise your... Oh, yeah, that one always works.
Oh, yes. All right.
So after working hard, they find that Mikola in his wisdom made a commit. So they said, easy, we're going to roll back.
This is easy, right? All we need to do is take the previous checkout and, just let it go to production. Throw out tests, CI servers and everything. It goes to production and fixes everything, right?
I have bad news for you. I just tried. It doesn't build. It says there's this thing called the left pad.
Well, it's not possible. We just built it 2 hours ago and everything worked.
I don't know. It says cannot download a dependency left pad.
Okay. So, anyone remembers left pad?
Does anybody know about that?
Yeah, no. So we'll have to explain.
We'll have to explain.
Yeah. Okay. So
JavaScript people, they like to divide things into small things.
I think they went to the conference and thought about dependency management, third-party dependencies, and they kind of took it very seriously. They have modules for everything, including one nice module, 11 lines of JavaScript code that pads strings from the left.
Well, we just said we celebrate the code that we didn't have to write.
Exactly. And in JavaScript world, apparently padding strings from left requires a library.
12 lines of code.
11.
11. I'm sorry, 11 lines of code.
11. Right? So here goes the story. All the internet depends on those 11 lines of code directly or transitively. And a year and a half ago, the central registry for JavaScript code called the NPM registry had a big fight with the author of those brilliant 11 lines of code. So
he removed them.
Right? So this guy kind of took his packages with him and moved out.
Now, the NPM package manager goes, well, I'm rebuilding your code. I should check for new versions just in case, but I should also check what is no longer there and remove it. Because that's what you do in the middle of the night.
Of course, right? So all the internet broke and hell broke loose, and including our guys that has to actually write those 11 lines of code by themselves.
Thank God they found them in the cache. Anyhow, the guys rebuild the code, publishes everything, but the moral of the first act is this firefighting of 3 engineers to keep the system up and running continues at this stage. And if you ever worked on the early product or in a small company, you probably know how it feels.
Let's see. Who actually been in this firefighting mode almost every day, a lot of nights, a lot of weekends? No one.
No, I don't. I think the rest are too ashamed to admit.
No.
Okay, so let's see what happens next. Step 2. We call it the smoke alarm installance or reactive ops.
Improvements. Right. So smoke alarms will help us make sure that the fire won't strike twice in the same place.
Right. There's nothing more embarrassing when a customer like Andrew calls you and says, hey guys, did you know that your system was down?
We're going to talk about that. So let's start with setting up the stage first, right? Let's see what's new, what happened since the last act. New and people.
26 engineers, they raised some more money.
They
hired the whole human being that knows ops. That's amazing. They figured out that that thing exists.
We'll talk about that. Well, around 100 customers, they're growing nicely.
They run a successful conference.
Good job.
Right?
Okay, so they got really tired of waking up for every customer call. So they hired a bunch of poor guys to do that instead.
To answer the phone calls early.
Right. And they also have now a little bit more evolved process.
Well, they have about 3 or 4 Scrum teams, so Scrum seems like an appropriate process, nothing fancy. They've started doing exploratory testing.
Who knows what exploratory testing is? Okay, and what is it? I think someone saw
Somebody
our
may
talk.
have seen this talk.
Yeah.
Fancy name for manual QA.
It is a fancy name for manual QA. Right?
But it is important.
Yes, yes, because there are bugs that you didn't think about that you need to check, and we saw what happened in the last act, right?
Ops, well, they have one whole human being that knows what to do.
Right. So yeah,
Should
he
be
knows
enough.
what to do. Developer on call. Okay, this is an interesting one. So you remember they have this support team, and those support teams are the guys that say, "Did you try to turn it off and on again? And did you close all the windows?" And that's pretty much it, right? This is where their expertise ends.
Yeah, but most importantly, they decided that those guys shouldn't wake up everybody on the team. So somebody gets the designated duty, maybe for a week, maybe for whatever period they decide, to be the person who gets interrupted so the rest of the team can focus on their jobs. They know that they're going to be interrupted. So
this is our developer on call. Well, and of course, we need to figure out how to
fix
manage
the logs,
logs.
right?
Yeah,
You learn that doing logs and time zone acrobatics is not fun.
All right, so this is all done. Now, tools evolve a little bit, right? So they still have Jira, but now they have some kind of a knowledge base. It can be Confluence, Wiki, a shared Google Doc, or whatever, something that the support team will use to troubleshoot, and maybe the developer on call will use to figure out what's going on. GitHub stays, Travis CI, it's all fine. Something to cache their dependencies and the artifacts that they build.
JFrog Artifactory, I heard, was a good product.
Right, you remember the t-shirts? That's why.
Sumo Logic for log management, things like Logly, or if you want to go the open source route, Logstash, Kibana, everything's in one place. You can search it, you can put alerts on it, which is a poor man's monitoring system, but it's not bad. It's a great start instead of trying to go through Amazon CloudWatch and log 20 logs.
Pingdom. Anyone old enough or miserable enough?
I see a hand over there.
Or miserable enough to know what Pingdom is?
No, there's some hands.
Yeah?
So Pingdom is the sophisticated monitoring system that allows Android not to have to call you when the system is down. It will call you by itself. It monitors a URL every few minutes. It goes, "Are you up?" The thing goes, "Yep, I'm up." So at least they know if something goes down, they'll get called before the customers do.
Right. So we will prevent this very embarrassing experience of the customer calls and said, "Guys, do you know that your system is down?" And you're like, "Let me check on that." That's not what we want.
No.
So this is solved.
So let's see what happens. Maybe you can guess when a startup raises a round of money and hire a bunch of people, what do they do first? They celebrate.
Raised a bunch of money. Good reason.
They go home, and then something different happens.
Well, remember, Friday 3 a.m., everybody drunk, they just had a party. Guess what? Customer calls.
We are running this promotion with American Express. If you pay us using Amex, you get better points. Nobody can make a transaction.
But Visa and MasterCard work.
Everything
the system
works.
is up
Yeah,
because now we have Pingdom. Only American Express won't work. So now we have support guys, right?
Yeah.
And they are the first line of defense.
They
What
could-
do they do when customer calls with such a major problem?
Come on, you should know it by now. The panic.
And they call
The developer on
call. And what does the developer on call do when they call them? Here you go, they learn. Nice job. Okay, now the thing is, now they have the developer on call,
Yeah.
they have knowledge base, and then they charge again. The developer on call opens this, you don't need to undress now, leave it to the end. And the developer on call goes like, okay, I see a problem here with American Express, and the problem is I didn't write this code, I don't know it.
But I know who did.
You know who wrote it?
Mykola,
Mykola.
the founder. He had a great, brilliant idea coming home from the party again.
Right, so he tries to call Mykola, the problem is that Mykola is completely wasted.
It happens.
Yeah, so he parties the hardest, and it's kind of hard, but eventually
He gets to the logs, goes into the Sumo Logic, goes, I think I've seen this problem again, says the queue is full. I think here's what you should do. Purge the queue.
No, it's only some
Get
transactions
some
there.
customers to, and resize it to 42.
We'll talk about that. So, right.
So they do it, they save the system, customers are happy, but this is the stage where something else starts happening at the company. on Monday, when everybody is less partied up, they get together in the room and start having a conversation that is much more reasonable than they used to during the firefighting stage, where it's the blame game, it's your fault. They start to try to figure out what happened this time, and ideally they do it in a form that you may have seen before called the root cause analysis. We have an example for you.
Right. So that's a true RCA
from one of the products I used to manage not that long ago.
But we will try to mimic it to our problem of American Express failed transactions.
We have obscured certain things to protect the not so innocent, but in a typical RCA, you have the date, the environment, and it happened. Ideally, you have some kind of reference so you can remember it. You have the times when things have started and stopped. And then you have some basic symptoms.
Your system was down for 24 hours?
This was a partial service degradation.
Let's call it that way.
Partial service degradation, right? And then you have a list of events. And if you unzoom your magic thing so people can see the sample, right? You see the timestamps, you see a bunch of things have happened.
How do you even gather those things?
We have an actual legal secretary sitting in the middle of the room
with
those tiny little special typewriter, and she's making the notes.
No,
yes.
Seriously, how do you gather that?
In real life, most teams today have a hip chat room or a Slack room where they'll get together for an emergency and start logging certain things that have happened, because the most difficult things after a Friday night firefight like this is Monday night to remember what was the right sequence on event and where things went right and where things may have gone wrong. That's what we do. We cut and paste from that chat and extract key information so we know that.
Sounds good. Okay.
The next section is symptoms. The symptoms are extremely important for the knowledge base, so the developer on call, if this problem ever happens again.
So in our example, going back to our example, the symptoms will be American Express transactions fail.
Yeah. Or one of the credit card types was not working, queue overflow, right?
Right. I think queue overflows goes to another section. Let's talk about that.
Well, it could be a symptom as well, right? And then you actually do the analysis of what actually happened, right? The queue wasn't set to the right size, et cetera, et cetera. You write it up. Why do you do it? It is painful, right? Like, if you haven't been through a process of having to introduce this to a company, it's painful to do that. You do that so you can improve. You do that because most likely the customer will ask you, and we'll talk a bit about that. And you do it most importantly to identify the root cause.
So this is where the queue overflow is going. Right.
The queue was too small,
misconfigured, too small to handle the transaction.
And the most important part of this document, for all of you guys, you've probably been through this, is the next steps. And those next steps have to be actionable, right? There has to be a defect ID. Because there is nothing more painful than to go on call, be waking up on Friday night, and see this problem the next week you go on call and the week after, right? You want to know that the situation around you is improving, and therefore you have to be able to track what happened and fix those root causes. And that's the act of smoke alarm installing.
That's the difference between firefighting. Every week I have the same problem that I fixed last week, and this stage in which you install the smoke alarm detector
to make sure it doesn't happen again.
And you are sure that this bug won't happen again. Going back to our example, you remember that we decided that American Express queue was overflown, and the fix was to resize the queue. The answer is, the question is, what do we resize it to?
42.
42. How do you know?
Trust me, I wrote this code.
42 will be...
42 will be fine.
It is enough. Okay, so this is how it works in this system. And this is something we will have to talk about as well.
And realistically, I don't have any better data right now.
There you go.
So retrospective is the key thing you have to introduce to your process, whether you guys are working on part of the team or you're operating the entire product. That's what allows you to introduce the act of continuous improvement. You've got to be able to figure out what's going on. Now, you would think, we mentioned that those RCAs, customers can see them sometimes. And the good ones will ask you, and you would think, like, that's pretty embarrassing and painful to show it to a customer. They will all quit, right? How can I show Andre that, we did something as stupid as misconfigure the queue? He will quit us and go to a different competitor. Well, let us show us an example to the contrary.
And yes, so you might think there are some minor incidents that we can easily tell our customers, well, this is what happened, it won't happen again. We installed the smoke alarm detector and everything's good. But then you think, okay, there are some failures that your customers won't ever forgive you.
Are there?
I think one of those examples would be losing customer production data in the cloud.
That's kind of one of the worst things you can do to your customer as a vendor of software.
If you are a cloud vendor and you have something as a service and your customers actually trust you with their production data, shouldn't you guarantee that it won't be lost? And if it is lost, this is the end of the line for you?
Maybe. Let us see an example. Anybody seen this? This was fun for us. Baruch and I live in California, so this was unfolding midday for us. We were watching this like a slow motion train wreck on Twitter. That happened.
Yeah, so some guy, we call him team member 1, deleted a production database with customer data. And,
but don't despair, like GitLab is not a small company, right? They must have a process to restore
stuff. First of all, let's not go out of proportion. That happens. Who of us didn't delete a production database with customer data?
I know I did.
Yeah, I think
okay,
everybody did.
The rest of them are ashamed to admit to.
Yeah, no, everybody did. That's fine. That happens. And when that happens, what we do next?
Backup.
We restore from backup. Easy, right? Let's see how it works for these guys.
Let's see what happens. So this is the actual RCA they published on the website. So, well, the regular backups only work in 24 hours. Team member 1 didn't really know where to find them.
So we don't know where the backups are.
Team member 2 found them, that only a few bytes in size.
And when we found them, they are empty. But you know what? There are SQL dumps that are actually kind of backups.
But the version of SQL was wrong.
So no dumps were created and they were soundly felt.
But we have disk snapshots.
Not for the database.
Oh.
But replication.
Replication.
Okay. The replication procedure is super fragile, prone to error, relies on a handful of random shell scripts, and it's badly documented, which is a nice way to say we don't have replication.
Don't despair. I heard we back up to S3.
We do, but all the buckets are empty. Well, in other words, out of 5 backup and replication techniques deployed, none was working reliably or set up in the first place. They lose 6 hours of customer data.
6 hours. This is probably how their customers should feel.
And yes.
Like that.
And
yes.
This is what I thought about it. And I was like, you know what, guys? We were speaking with our colleagues. This is the end of the line.
That's it.
I mean,
GitHub just won.
Yes, GitHub won, GitLab won't exist anymore. In a couple of months, they won't have any customers and they will quit.
But you know what? That truth and transparency gave GitLab something. Their customers congratulating them on them. They wanted to know they're going to do something that makes sure that this problem doesn't happen again. And team number 1 got promoted.
Yeah,
gotten some cookies and
what happened?
credits.
Yeah, here we go. No, I just wanted to, one of my favorites is Je suis team member 1. This is just great.
Yep.
Right, so actually another retrospective that GitLab did was a blog post about how this guy, team member 1, is doing. He was scheduled to get promoted before this accident, and he actually got this promotion despite what happened. This is the guy, his name is Yorick, and he has the most amazing description.
Yeah, for those that can't see the bottom of the screen, it says database removal specialist at GitLab.
That's a good sense of humor.
That's a good one, right? So the key about this stage, no matter how badly you screw up, is to show to yourself, to your team, and to your customer that you're doing something in the form of a smoke alarm installing to make sure it doesn't happen again.
Right, so another outcome of this RCA was, yes, now we actually have 5 different backup and replication techniques, and it won't happen again.
All right. So this is a Greek tragedy. As you know, everybody has to die, so this is our Act 3, the perfect storm.
Where everybody dies.
Let's see what happens.
So first, it starts very good. The guys raise more money. They have round B of investment now, and they hire tons of new people.
Including 5 more people with ops background.
And a whole human being of a performance engineer.
You know, like, you need to have at least one Shipilov in your team.
And you cannot afford much more, by the way.
Yeah, he's expensive.
Chief architect.
Ooh, this is where people get scared. The chief architect is in the house.
All right. Customer success team. Now, who are those guys?
Remember, 74 people knew, about 100 people on the team. This, complex system, not everybody can know what's going on, and the volume of issues that are coming from the customers when we look at the customer count is high enough that it's worse now to stop interrupting people during their day. And depending on how you structure that in your team, sometimes you have a customer success team that are permanent. I had very senior engineers who enjoyed the act of being the Sherlock Holmes and finding who killed the patient. By the way, it was them most of the time anyway. And that they stayed on that team permanently. Sometimes you rotate people in and out onto that team, and their job is to be interrupted so nobody else has to, and you do it either per sprint, for a month, or for a couple months.
So you remember how the developer on call in the previous act had no idea about what's going on with American Express? That won't happen anymore because they have a representative from each and every aspect of the system to answer when the support team needs them.
Being a bigger startup now, 100 people, so they have a legal person now. They have a CFO, somebody has to mind the cash.
They have around 1,000 customers. They are successful because, as we started with, they are good guys.
So the process obviously has to evolve. 100 people, probably more than one locations. So they adopt something called SAFe, Scaled Agile Framework. It's a slightly more complex framework above basic Scrum.
I would say this was the understatement of the year, slightly more complex.
And that's the difference between Baruch, who is a developer advocate, and me, who runs processes professionally. I don't get scared by process. Process is there to manage risk and to organize certain things. Like, for example, as the developer, you probably want to do some cleanup on your team, or you want to improve the architecture. That has to be allocated somewhere, and SAFe defines a thing called an architectural runway. Right, with a product owner, who is typically that chief architect we managed, somebody who can represent the needs of the development team and allocate and prioritize the work that needs to be done there.
QA, so we spoke about explanatory testing, we spoke about automatic tests on different levels, but the system is now really complex. So there is a new function that is in charge of involving a fully blown system testing into the DevOps process.
For example, one of the products I used to manage was an APM product, Application Performance Monitoring, where in order to test the product itself, it's like a profiler, you have to start a bunch of microservices, you have to write a bunch of software, you have to deploy it, you have to have environments ready, so the developers that write the actual profiler or the APM system have a place to test and know how to test it, right?
Right, so this have to happen.
And somebody has to care and feed it.
And automate it so it will work in the DevOps matter without human intervention.
Yep.
Well,
wait. They have an ops team?
Well, this kind of contradicts the whole idea of DevOps, isn't it?
I don't know, maybe it doesn't.
Well, there are actually two ways in the current state of things to run DevOps. One is, I would call it the Netflix way. Netflix way is only hire the best people, pay them way above the market, don't let them do any critical work, but instead just stream movies, and then do proper DevOps when everybody do DevOps.
Well, everybody
have
has
access to root, everybody know what's going on and how the software is built, everybody can interfere with this software process, not a lot of legal obligations, they only stream movies, and you can even kill your service in production for the fun of it and everything is good.
But in reality, as we've seen even in the first acts, ops is a specialty, and there are people that know, for example, I'll give you an example. Baruch and I were prepping for a conference a few days ago, and my logs for my Lambda function on Amazon were not making it to the right place. I'm not an ops guy. I don't know Amazon services all that well. Apparently, I was missing one permission somewhere deep in the...
permission role schemes.
Yes. Yep. Right? So ops is a specialty, and sometimes you're going to be working on the product that requires what's called the separation of concerns.
So there are two, I would say, two main goals to create this kind of team in the organization. First, someone has to teach everybody else how to do DevOps. Someone has to teach the developers, as Leonid was doing, where the logs are and how to access them and what it takes to actually make them available.
Somebody has to build a tool chain that maintains and updates the CI process and the CD process.
Someone has to configure Docker, and we couldn't do a whole keynote without mentioning Docker.
Docker.
Docker, now we're good. Someone has to configure it, someone has to teach other people to use it, and there is something else that we're going to get in the couple of bullets. Right, escalation path, we spoke about it a little bit with the developer on call.
We did, right, the developer call, but sometimes the problem can be big enough where the developer on call may need a manager's help, right? So you typically see at this stage a manager on call showing up. But the more interesting thing is a good escalation path typically goes all the way to the CEO.
That doesn't make any sense. CEO usually won't write any code and won't contribute anything to the bug fix that will solve the problem.
Well, realistically, it happens for two reasons. Number one, sometimes the problems are big enough where you do have to wake up the CEO because he has to either go play golf with some of the key customers, or based on my experience, if the escalation path says you have to call the CEO's mobile number if you couldn't resolve the problem of this severity for 6 hours, it's amazing how many problems get solved in 5.5 hours.
Magic.
Just magic.
Magic. So yeah, SOC 2 or any other legal...
PCI DSS, HIPAA, or some kind of other standards under which the company is now being audited.
So this is a regulation thing. They do stuff with money. They have to comply to a bunch of regulations. And one of the funniest regulations, for example, in SOC 2 is that people who write the code are not allowed to deploy this code to production, which again is a brutal violation of any DevOps concept that we spoke about.
Or is it? It doesn't say that you're not allowed to submit something into a CI toolchain that automatically runs it, tests it, perform all the basics checks that the company determined are appropriate, and deploys it to production. What it does say is that the people that control that toolchain should be the people that write the code. And that's the ops team.
That's another reason for having it. Non-functional backlog?
Yeah, remember we talked about those things like from RCA. On occasion, you have to upgrade the library because there's a security vulnerability, like one of the vendors in the US forgot to do with Struts 2 recently, Equifax. You have to do the care and feeding of your system, and that's where the chief architect can be your best friends. This is somebody senior enough who is the seat at the table who can say, this is what we must do to make sure the system doesn't fall apart, much like we all wake up and we brush our teeth and we don't think about it because we know the consequences of not doing so.
Right. Tools, again, evolve as well. So but what's new here? Configuration management.
Right, APM, like they've realized that trying to guess the size of the queue is not really viable. So they're starting to collect some metrics from their production environment so they can use it when they try to figure out how to code, how to configure, and how to scale the system.
And in other news, Mikola got promoted, and he is now head of development. By the quality of the greeting card, you can see that people don't really like him.
Yeah, apparently not. Well, let's see what happens.
Well, action. As you remember, they raised money. What do?
They party.
Oh, yeah.
Something different, though, happens this stage. You know, the party on Friday, they get through the Saturday, Sunday.
Nothing happens. No calls from customers during the weekend, and Mikola has his good night's sleep. But then on Monday...
Few things happen. Number one, the legal gal, she goes to the conference. By the way, they have conferences like that, very exciting stuff. They talk about Apache licenses, BSD, and LGPL 2.2. Comes back and says, hey, Mikola, I just got back from this conference. Heard about this thing, LGPL 2.2. Do we have any in our code?
LGPL 2.2? So,
well, he doesn't have to panic anymore. Absolutely. He has people.
He is a boss now, so he's going to send his developers to look for licenses. Now, the good news are the licenses are in one place.
Yeah, the POM file, the NPM file, are they?
Yes, they are in one repository. But there are tons of sources for this license information. POM XML, NewSpec files, package JSON files, license text files, headers of the files, and the most amusing ones,
no license.
Components without license.
Those are the best.
And let's say they actually managed to find this license that the legal gal tell them not to use. What do they do now?
Remediate.
What does it mean?
It's a fancy word for take it out, put something back.
Which will take them a reasonable amount of weeks to implement.
But the product managers want features.
And the release is tomorrow. So yeah, day after or a couple of days after.
Remember to raise the money. The CFO comes to Mikola and says, hey, Mikola, I'm doing the budget for next year. Got to figure out how much money we need for servers.
You know what? 42.
Seems like a strange number. Why 42?
This is what we're going to pay for production servers next year.
You sure?
Absolutely.
Okay.
And you know why he is sure? Because he doesn't really care. No one will shut down production servers if they actually use more than 42.
And unfortunately, he doesn't know any better.
Yes.
And then lastly, does anybody know who this guy is?
Will it blend? Here you go, right? I don't need to explain. I don't need to explain.
Thank God, because if you have to explain the meme, we have to change the meme.
Oh, yes. Will it scale will be our, the next question.
The sales guys call, hey, Mikola, we have this prospect. They're about 10 times larger than anything we have sold so far. Are we okay to deploy them? Should we close the deal?
So the question is, will it scale, actually?
Yeah, will it? But then...
You know what? I can ask my developers, right? I'm the head of engineering. I can ask my developers, and they know better, right? Who knows will the code scale if not the developers? So he goes to the developers, and they're like, sure, absolutely, of course it will scale.
We wrote this.
It's great. It's super scalable.
Plus, we have this whole human being of performance engineering. They know.
All right, they know. How do they know, by the way?
Well, they have no tools or testing, so
And I think they have this gut feeling that their code is very solid.
I look at the code, looks solid to me.
Looks very scalable.
Yeah, 42.
Well,
simple number, power of 2.
Yeah, no, it didn't scale. No. Everybody died.
Everybody dies. It is unfortunate, but this talk was written in US.
Yeah, we are from California.
Like in Hollywood, we're from California, so like in Hollywood, there's always a happy ending. In our case, the mascot for the happy ending is Smokey the Bear, which is the mascot of fire prevention in the United States.
By the way, you are explaining a meme?
He's not a meme, he's a very important character in fire prevention. You should know, we live in California.
So let's talk about how we prevent fires from happening at all. Something that we call proactive improvement.
Yeah.
What process should change in order to stop those things from happen even once?
Well, obviously, let's start with the obvious. Performance scalability testing. Ideally, you should do it both reactively by instrumenting your production system well with tools like APM, so you can watch the trends and preempt them, and proactively. That's where the system test teams come in. They can help you with that.
License and security management. So we spoke about a reactive way of doing that when the legal come and shout at you, or when you have to probably pay millions of dollars in fines and legal actions against you because you had a security vulnerability. So instead, you'd better take care of it proactively.
Right. You start looking at your performance trends maybe once a week, maybe once a month. You start looking at your key indicators and you start trying to put stuff on your non-functional backlog before things flare up with a major fire.
And a completely related but a new thing, non-functional definition of done, which is kind of differs from non-functional backlog.
Yeah, the non-functional definition of done says, hey, if you're introducing a new service, a new component, maybe a new microservice, those are the things you must satisfy before it's considered done. Things like, it should have a monitoring endpoint. It should have logs. The logs should have timestamps. Ideally, you took all of that and you codified it in a template.
How can you codify logs, endpoints, and how the logs are formatted?
Like any other keynote that wouldn't be complete without mentioning Docker.
Docker. What?
Docker.
How do you write it in Docker?
You have a base files, you have some base templates for your services for whatever language you write them, right? Ideally, you don't have it just written on Confluence. You have something you can inherit from, and then you can focus on your
You
service.
basically have a base image that takes care of all that, and you just extend from it and it takes care of for you.
Or maybe you Spring Boot.
Spring Boot, I don't know what it is. Right. Tools, there are tools that help you, and Docker should probably make it to the slide after all. There are tools that help you to predict some of the stuff that you do, like JFrog Mission Control, or tools
Something like
help
Blaze
with-
Middle, right? You want to do proactive performance testing. Performance testing is hard because load generation is hard, but nowadays you can do it in the cloud with service like a Blaze Meter, or testing a service that has to go and integrate with a third-party endpoint. Maybe your partner did not provide you with a test endpoint. You can use a product from a category of products called service virtualization. Think of it as a mock object for an API, right? So you can replay and test your functionality.
And bunch of tools that do security and license management for you, and of course JFrog X-Ray is one of them. So let's talk a little bit about how those tools help you to fight those problems that we had.
We're going to talk about our favorite one, the most sophisticated one of them
Oh
all.
yeah, now this is good. Now I'm not sure if those guys are prepared. They are good, but we're going to show you now a very sophisticated, very expensive tool that you might want to learn someday in the future to predict your expenses.
It's called Excel. Right, this is an example from a real product again that I used to manage about how did we end up spending our development time, right? And that helps for several reasons. It helps me as a head of engineering to talk to my head of product management and say, hey, listen, we have to care and fit the system, and about 35% of the time typically is spent on any other team that I've seen there. In our case, we deemed that our engineering velocity was not enough. We were moving too slow, so we've agreed to invest, the top blue slide, 6%, into an engineering velocity initiative, right? And then somebody who owned that non-functional backlog, whether it's the chief architect or head of engineering, could determine what to do with that capacity, right?
So the most amusing part in this slide for me is that, you know, you picture a sprint in a development organization as working on a feature, right?
On value.
Next sprint, we will deliver some feature, some value, some new functionality to our product, and then you look at it and you are on 13% of actually doing that, and the rest of the pie goes to tons of different places.
The key here is to know, and the key here is to use the data to help you evolve your process, and I think the next example that is coming up is one of the favorite that I know Baruch has.
Oh yes. So let's talk about how this kind of data, or data in general, can solve us this problem of the quality of our product.
How do you guys know whether your product is good or bad?
How do you know if the product is good? It raises money, it's good. What can stand between a product and raising money? It's bad quality. How do you know that the quality is good?
Feedback. In what form do you get that feedback typically from your customers?
There is a page. How customers
They call
express
support.
their feedback?
I expressed some feedback to Google recently.
Yes.
I called support.
You call support, right? So I would say customer issues or defects are the ultimate way to express, to analyze the quality of the product, and let's do that using, again, the sophisticated tool that I showed you earlier, Microsoft Excel. So this is a picture from one of Leonid's product, and we broke down the defects in this product by the severity. And let's take a look at what we have here. 65% of all the defects are either severity 1, which means nothing works, and severity 2, which means
doesn't work.
Something works, but generally nothing works.
Right? And those are not just the customer incidents calls to support. This is the stuff that support handed off to the engineering team to go fix.
Right? So, and I will ask you, and we will shame Leonid here a little bit, what do you think about the quality of this product? Is it good? Is it bad?
You can just shout.
It's pretty bad. I mean, 65% S1 and S2.
Or is it? This is the conversation I had when I joined this product to help them with some of the quality issues with my peer who was running the support organization. He brought me some data. I said, you know, The data doesn't look good, but let's make our decisions on the data. So we looked and projected this data slightly differently. We started gathering, and if you ever been asked by your head of engineering to make sure you update Jira and make sure you put the correct resolution into the defect when you close it, probably that's why. We started looking at how those defects that were coming in getting resolved. And if you look at this, well, only 19% of the defects that were handed to engineering required a code fix to be resolved. The rest of them, 52.3% out of my 33% budget you just saw on the previous slide, were resolution provided or information provided.
Let's translate it to a simple language. What I say here is that most of the half of those severity 1 and severity 2, those horrible, horrible bugs, was just telling the support how the product should be used.
Now, why could it be? Our conversation with the head of support didn't go, you guys are stupid, do something about that. We started looking at the root cause. We found that we were lacking in documentation in some area, we were lacking in the logs in some area, and quite frankly, I sent my engineers to help support get the training because I had the numbers to show both them and my support team that we're going to reclaim that time back, right? So with that, we move to the last stage of our presentation, the epimyth. Who knows what an epimyth is?
Anyone? What is epimyth?
The only person who knew was Baruch's wife, but she has a degree in Greek.
Oh, here we go, someone guys. What does it mean? He's not sure. Okay, yeah, I think there is one person in the world who knows, and that's my wife.
Well, she has a degree in literature, so.
Right.
Epimyth means the moral of the story, and we have a few for you. Number one, scale is a scale.
What does it mean?
What it means that in order to achieve some of the things we were talking about, you have to traverse several steps, and you always start with the firefight. And if you ever want to get out of the firefight, you want to move to that stage of proactive improvement. You have to understand why things are breaking and what are you going to do to make sure it doesn't happen again. Right? This is the stage where you build up your bulk of your process, bulk of your tooling, bulk of your experience so you can move to what we call the proactive improvement and get ahead of the problems. So there is no way to bypassing the stages, and if you find yourself in the stage of reacting improvement, don't despair. Majority of the firms when we did this analysis, about 70%.
You know what? Let's do the voting now. Who is in the firefighting mode? Waking up at night, almost every night,
and it feels like going back to the catacombs.
Fixing the same problems over and over again? No one. Okay, who is in the last stage of proactive improvement, using data for predicting costs, performance, quality?
Anybody?
No.
A few things. No,
few hands.
Few hands.
Okay. All the rest are in the middle, which actually is exactly where the market is.
So don't despair.
Yep.
Few other lessons.
Right. So as we spoke about, tools, process, and people all have to change in order for us to achieve DevOps, and especially DevOps at scale. And we have, I would say, 3 main takeaways for you to take what need to be changed in order to achieve kind of a next step.
Number 1, you build it, you own it.
This is the basic of DevOps, right? We are talking about every stakeholder taking responsibility for what they do.
Yep.
Right? Developers deploy their code to production and own it.
Number 2,
data is the key. And Excel is okay for that.
You cannot make the right decisions on what to fix and how to get out of the ditch if you don't have the right data or if you don't spend the time to get the right data, right? It's painful to close the defect and fill all those required fields. Sometimes they can come in handy.
And talking about painful, I think our favorite takeaway from this talk is pain is instructional. The best motivation to go through this process is to experience it. And as I mentioned, I'm the vendor of a couple of tools that, as you saw, are introduced in the later stage. So usually one of our tools introduced in the second stage, and the majority of them are in the third. And when people ask me, why do I even need the stuff that you do? My answer is, if you didn't feel the pain,
you don't need it.
You don't need it.
Yet.
The good news for us is
pain is inevitable.
Pain is inevitable and is instructional, so
don't be afraid to bring the pain to the source if you want to progress. With that,
Thank you very much. Couple of links.
Baruch at Twitter.
Igolnik on Twitter.
This was JavaDay Ukraine 2017.
That's when you tweet about how awesome we are. Don't forget the hashtag. And this is all. Thank you very much.